Hello and welcome to Chapter 3.1 in the Quantway Core book. So this lesson is not going to be specifically about fractions, but an understanding of fractions and how they work is necessary to being able to understand what's going on in this chapter. So we're going to start with a quick review of fractions. So the first thing we're going to cover here is simplifying fractions, and here's how that works. So let's start with the fraction 4 over 6. So if we want to simplify this, what that means is to rewrite this as a different fraction, which talks about the same amount of stuff, but uses smaller numbers. So in other words, if you weigh 4/6 of a pi, we want to find another fraction that talks about that exact same amount of pi, but uses smaller numbers. And here's how that works. So 4 over 6, we can factor both the 4 and the 6. The 4 we can write as 2 times 2, and the 6 we can write as 2 times 3. And what we have going on here is that there's a 2 on both the bottom and the top. So we can cancel those 2's out, and we see that 4 over 6 is the same as 2/3. 4/6 of a pi is the same amount of pi as 2/3 of a pi. So here's another fraction. So let's say we have 7 over 14. So what we want to do is find something that we can cancel out of both of those fractions. So we can factor the top, like 1 times 7. And you'll see why I put the 1 there in a minute or a second. So, and 14 is 2 times 7. So in this situation, we have a 7 on the top and the bottom. So we can cancel the 7's out, and that leaves us with 1/2. And a particular type of fraction cancels really easily. And here's the kind of fraction I'm talking about. So suppose we have the fraction 30 over 100. In those other two instances, I had to factor them first. In this case, I see that since they both end in a 0, that they both have a factor of 10. So I can just cancel those zeros out. And that's something you can only do with zeros, but it's a pretty nice trick. So the next thing we're going to do with fractions is multiply them. So let's take these two fractions here, 2 over 3, and multiply it by 5 over 7. So the rule for multiplying fractions is really simple. In this case, to get the answer in the numerator, we just multiply straight across the two numerators. And 2 times 5 is 10. For the denominator, we multiply straight across again. 3 times 7 is 21. And that's all there is to it. Here's another example I want to do. Let's say we have 3/8, and we're multiplying that just by 5. So this seems a little confusing. Is the 5 on the top? Is it on the bottom? Is it in both places? Well, the answer is 5 is on the top, because any whole number is really just a fraction over 1. So we have 3 over 8 times 5 over 1, and in this case, we get 15 over 8. So there's a trick with multiplying that's going to be crucial to what we do in this unit. And to illustrate that, I'm going to give us another fraction here. So here we have 1/5 times 5/8. So the rule stays the same. We absolutely do just multiply straight across, but there's something we're allowed to do with multiplication that's going to help us out here. So recall when we simplified fractions, we canceled out a factor that appeared on both the top and the bottom. Like if there was a 2 in both places, we canceled out the 2. Well, when you're multiplying fractions, you can cancel any number on the top with any number on the bottom. So I'm going to take this, see there's a 5 on the bottom of the first fraction and on the top of the second fraction. So I can cancel that 5 out of both places. And if so, by canceling out, that means dividing. So what's left when I cancel out a 5 in both places is a 1. So now when I multiply straight across, I get 1 over 8. So this works also in our whole number example here. Let's say we have 6 times 5 over 6. So we're going to put that 6 over 1 so that it plays nicely with that other fraction there. And when we do that, we see that there's a 6 on the top of the first and the bottom of the second. So we can cancel that 6 out. And when we multiply straight across, we get 1 times 5 on top, 1 times 1 on the bottom. So we get 5 over 1, or just plain 5. All right, so we're going to take this multiplying fractions thing just a little bit higher. And we're going to line up a bunch of fractions and try to multiply those. So the rule is still the same. If we wanted to multiply these, we would just multiply straight across all of the numerators and straight across all of the denominators. But where we're going to focus on here is the cross-canceling on the diagonals. And this works pretty much the same way. You can cancel any number on top with any number on the bottom. And in this case, they're lined up, so I don't have to go. I can just go next door for the canceling. And here's what I mean. So I'm going to cancel this 5 down here with this 5 here. And I end up with a 1 in both places. I can cancel this 2 down here with this 2 up here. End up with a 1 in both places there. And I can cancel the 3's. And when I've done all of that, I now multiply straight across. And all I have left on top is a bunch of 1's. And all I have left on bottom is a few 1's and a 7. So that leaves me with 1 over 7. So the last thing that we're going to talk about in this video is rates. And rates are a very important part of this unit. So here's a rate that you guys are probably very familiar with. If you drive a car or even ride in a car, you could look down at the speedometer and see a rate right before your eyes. For example, 55 miles per hour. Now, the way we are going to write rates in this section is as fractions. And here's what I mean. So 55 miles per hour means 55 miles in 1 hour. 55 miles in 1 hour. And that's the way we usually think of them. Here's another example. Suppose you are buying pizzas for a party and you know that it takes, from past experience, that 5 people collectively eat about 2 pizzas. So we can write that as a rate also. 5 people over 2 pizzas. Now here's the interesting thing about rates in this particular unit that we're going to do. And that is that we are allowed to flip them. And here's what I mean. So this top rate means that we go 55, for every 55 miles that you drive, it takes 1 hour of time. Well, what we're going to say, what that means is that for every 1 hour that goes by, that you will have driven 55 miles. And likewise, for every 5 people that you have, they eat 2 pizzas. And similarly, for every 2 pizzas that are eaten, you know that you must have 5 people eating them. So we can flip them and still be talking about the same information.